Alright guys, today we're going to work on classifying equations using the substitution method to make a table, and then we're going to graph and solve linear equations. So we've been working with linear equations for a while, right? And they look like this. What kind of form is this in? Slope-intercept form, right? So how do I know what type of equation this is? Just by looking at it.
Because slope-intercept form is y equals mx plus b.
Right. So I know it's slope-intercept form because it's in y equals mx plus b. Would I say that this is linear or that this is non-linear?
Linear.
What tells me that it's linear just by looking at it? I'm going to erase these parentheses because I had them earlier. So what tells me that it's non-linear? Ashai? If I was to graph that, what would it do? Give me a straight line to give me the slope and the intercept, right? So that lets me know it's linear. It also lets me know it's linear because if you notice here, I don't have any exponents, right? It's all just regular, so the exponent is 1. All right, so that's the linear equation. On your whiteboard, everybody should have a whiteboard in their team. They should have expo markers in their box. Make sure everybody gets one. On the white side of the page, I want you to write that equation. On the white side of your whiteboard, I want you to write the linear equation on the board. If you don't, you might have to write on the graph paper, Michelle. On the white side, you're writing the linear equation. And this time, we're going to say if x is 5, what would y be? So if x was equal to 5, what would y be? And when you're done, turn it right side up, side out. All right, show me. All right, good job. 17. Y is 17. Now, how did we find that? Now, notice a few of you guys didn't get to finish. That's okay. So, what method will we use, Emily, to find that? That's what method is that? What did we say we're going to use? And the outcome. Same word for plugging in. Substitution, right? So instead of just plugging it in, we're going to substitute. Remember, when we substitute something in, we have to make sure to do what around it? Parentheses, especially when you're dealing with a negative. So y equals 3 times 5 plus 2. And then a lot of you guys saw I ran out of time right there, but that's okay. So as long as you got that you were substituting in for x. What if I said this time, so you can erase x equals -1 instead? So are we going to change the method? No, we're still substituting, but this time, -1. When you're done, let me see red side. All right, show me. Very good. All right, awesome job. So everybody substituted in -1, so they got y equals 3x times -1 plus 2. 3 times -1. And then y equals, awesome job. All right, so this time, instead of substituting x, I'm going to tell you y equals 8. So instead of x, I'm going to tell you y equals 8. Do I change my method? No. I substituting, what letter substituting, right? Because this time it's Y. When you're done, right side up. All right, show me. Yes, very, very good. So, same concept, in place of Y, I have to put 8. I just have a little more work to do. Why is that? I have to get my X by itself. So Brandon said I have to get rid of my 2. So how do I get my 2 over to the other side? Brooke?
Subtract it.
Right, I do the inverse operation, which means I subtract 2 from both sides. So 8 minus 2? Right, I'm still looking to get my variable X by itself, so I have to divide it by 3. So X equals, awesome job. Everybody got that? One more. This time, instead of Y being 8, let's say Y is 0. Same method, substituting in your Y with 0. What you got? So a little more hesitation that time. Mostly because your answer is what? A fraction, and that usually makes you guys hesitate. Oops, so maybe I did something wrong. It's okay to have a fraction. So in place of Y, I'm putting 0. Still same method. I want to get my variable by itself. So what do I do first? Subtract 2. -2 equals 3x. How do I get x by itself? Divide by 3. Good job. So it is okay to have an answer of x equals -2/3. So I saw you guys have that and then you're like unsure, checking yourself. It's okay to have an answer. So let me ask you a question. All of these 4 that we just solved, what can I do to make sure that I solved it correctly? So in a minute, we're going to have 6 different linear equations that we have to solve. Some of you might want to second guess yourself. What can you do to make sure that you have the right answer?
You can plug in your answer to the first equation.
So you can substitute in your x and your y to see if that works out. So substitute, plug in. What else?
You could graph it.
A really great way, if you have graph, which the ones that we're going to have graph, you can graph it. And what should that graph do? If it's linear, it's going to make what? A straight line. So if you're graphing something and it's not a straight line, then you might want to check your calculations again, right? So let's just check the first one. It was x5, and we got y was 17. Thank you. So let's check that. What do I do to check that? In place of y, what do I put? 17. In place of x, what do I put? 5. Now, if this is correct, what should happen? This should be 17 equals 17, right? So let's check it out. 3 times 5?
15.
Plus 2?
17.
If this doesn't happen, then that means I made a mistake somewhere in my calculations. So if something is correct, it should equal the same thing. It should always be true, okay? Now, what you're about to do is take a linear equation like this and fill out a table. Using substitution method, fill in blank, and graphic. There are 6 equations on a card. There are some teams of 3, and most are going to be pairs of 2. So one person in each pair is going to get up, get an equation card like this. You're going to need scissors, glue, which are already in your box. So your equation card and your poster is up here. Everything else you should already have in your box. You need 1 per pair, okay? You're going to split this up. So each of you will do 3, and then after I tell you, we're going to come together to make sure that you did it correctly. So the A person come get a card and a poster. I have some on each side. So the A person in each pair come and get your material. Yep. Right, get your material. Oh, that way so they can get your material. Done. So work with your partner or your team of 3 and make sure that everybody's on the right track. Discuss, ask questions. If you need me as a team, raise your hand as a team, and I'm going to come over and help you guys, okay? So make sure you guys have the right answers. Check them if you need to. And then once you're sure that they're good, you can go ahead and glue them onto your poster. There's some examples of posters on the walls. Should be 3 and 3. Doesn't really matter what order you put them in. Okay, so once you're got and you're sure that they're right, go ahead and cut them out and glue them onto your posters. If you need to look at examples, you can look on the wall. Okay? So if you distribute that in, that's going to be blind, right? So then you will do it into that. So basically what we did was put a little bit of our form first. Yep. So, yeah, right, this is the y-axis, right? So that's the offset of y-axis. Yeah. You have it? Okay, this is a -1, right? So my slope, there's the -1.
Good eyes.
Remember, you use your clues, your sloping intercepts to make sure that you have the right equations. Got it?
See, this one right here is x is positive 2x, then you got the 6, so y.
Okay, so if you and your partner haven't started gluing, you should start finishing up so you can start gluing onto your poster. If you don't have all 6 complete, it's okay, because we're going to be comparing and classifying solutions in a minute. So if you don't have all 6, it's okay. So you can go ahead and start wrapping up so you can start gluing your equations onto your poster. Yes, sir.
I got like 3 finished.
No,
So y equals -1/2? Yeah. All right, and then it says y equals 4. So 4 here. So the first thing that we have to do, right, I want to move this over, so I'm going to do -4, What's 4 minus 4? 0. And then how do I get rid of that 1/2? The -1/2. Right, we can't divide fractions, so what do? Multiply by the reciprocal. So times the -2/1. So -2 times 0?
You want?
0. Okay? Alright, so make sure you have your 6 cards glued down before you start cutting the arrows. Wait for instructions. Chamber.
Instead of using the arrows that they have to draw
Yes, good question. So somebody asked if you can draw the arrows instead of cutting out. Yes, you can use, listen, Michelle. Instead of using the arrows, the question was, can you draw them? Yes. Instead of cutting out all those little arrows, you are more than welcome to draw arrows and to write the number of solutions. If you're giving me one solution, what else do you have to include? The ordered pair where the lines intersect at. So you actually have to give me the solution. Alright, so listen up. Almost all the teams are finished gluing. So I need you listening, so stop. Okay. You should have almost all 6 of your equations glued onto your poster board. If you don't have all 6, that's okay. We can work with what you got. Now what we're going to do is use our arrows. Before you cut out your arrows, or if you cut them out, it's okay. Just be careful you don't lose them. You want to talk to your partner and discuss how the 2 equations relate. So you can relate them any way you want. So this is an example of one that we've done before. So I can talk about how these 2 relate. I can talk about how these 2 relate. These 2, I've even had people who go and draw arrows and relate to on complete opposite sides. Okay, it is up to you which 2 you're comparing. So you're going to classify them. So how many different options do you have? What are your answer choices? Infinitely many? No solution? And 1 solution, remember? 3 different solutions. You can use, if you give me 1 solution, you have to give me the point where they cross, the ordered pair that they intersect at. You can use your whiteboard. You should have a graph piece of paper in there if you want a graph on there, so that it helps you to use to find that piece, that 1 point that they cross. Or you can use the graph transparencies if you're, rather than write on paper. So you can either use your graph, your whiteboard to graph, or the graph transparency if you need help to see the relationship between the 2 equations, okay? Alright, if you lose a little piece, it's okay. You can always just draw an arrow and write it yourself. You don't need to have those little cutouts.
So it's you want to
So I had a really good question that might help everybody. Someone forgot how to find that 1 common solution. You can either graph them on your graph transparency or on your whiteboard so that you can find where they intersect. Or you can use your methods for systems of equations that we've used before. And those methods are graphing, substitution, and elimination. Very good. So you can either use your 3 methods that we worked with before, or you can graph them on your transparency or your whiteboards. Either this paper right here if you need it, okay?
It might. Up here. Yeah, because, okay. At 5, this would be at 6.
Feel what?
Okay. What you're going to do now is my teams of 3, you guys are going to share. So you're just going to turn behind and share, okay? What you're going to do is you're going to take your poster and pass it to your neighbors. Y'all are going to switch. That way you can look and see if they have different comparisons than you. Check their work. Maybe they made a mistake and you can catch it for them. And you guys can discuss what went wrong or what they did right. You're probably going to find different solutions. Like they might have classified two different equations than you, and you can see a different way of looking at things, okay? So what you're doing is you're switching with your partner. You're going to find at least two different solutions that they found, and then give it back to them, and then we're going to share as a class, okay? So you're looking at your partner to see what two different solutions that they found, and how check their work. Make sure that they got it all right. So switch with your partner. You guys switch with the team behind you. Y'all switch with JD.
4 over 2 is 2.
What?
4 over 2 is 2.
I didn't do anything with 4 over 2. I did.
Ethan, 4 over 2 is 2.
Wait, which one?
C3. 4 over 1 common solution. So it's still a solid number. You divide by 2 over 1.
Yeah, I don't no, I don't think, yeah, 2 and 1 common. I got this.
All right. So I hear that a lot of you guys are finding different things, maybe finding some errors. So get together as a team of 4 or 5 and talk about the mistakes or the different solutions. Maybe they can help you see something differently so that you can talk to each other and learn from each other as teams. So teams of 4, get together and talk about the 2 posters.
Because this is a negative sum.
Yeah.
Okay, so, well, for one of
You guys get 3 and 5, right?
well,
What'd you get? It was. Okay, I can't say it. 12 and 4. Okay, wait. What did you get for 5?
Alright guys, can one team, one partner, one pair, tell me at least one solution that has no solution? So give me 2 equations that give you no solution. No common solution. Vivian?
Y equals 2x plus 4 and
Wait, excuse me, I have somebody being very rude.
okay, y equals 2x plus 4 and y equals 2x plus 1.
So what, see what?
It's C3 and C4.
C3 and C4, do you guys agree? Thumbs up if you think she's right, it's no solution. Thumbs down if you think she made an error. So what do you think? C3 and C4? Good job. All right. I need a pair that can tell me infinitely many solutions. So Michelle, tell me some infinitely many solutions.
Y equals 2x plus 4 and y equals 2x plus 4 and C4 and C1.
C1 and C4, do you guys agree that it is infinitely many? Or do you think she made a mistake? Good job. Jared, any opinion at all? Oh. All right, just checking. And so we have no solution, we have infinitely many solution. The last one is one solution. Can someone give me one solution? And someone who hasn't gone yet. Brooke.
Y equals 1/2 x plus 4 and y equals 2x minus 1.
And what is that? C what?
C2 and C3.
C2 and C3. Do you guys agree that that gives us one solution? Thumbs up, thumbs down. Let's just see everybody's thumbs. All right. What do you notice about the solution? So what clues can you use? I saw a lot of you using the graphing method. What clues can we use when something, especially when something is written in slope-intercept form? Michelle?
Check whether the 2 slopes are the same and the intercept's different, and you know that there's no common solution, so you just use kind of quick ways to figure out whether or not it has a solution.
All right, so quick, efficient ways to tell if something has a solution, she said, is to by looking at the slope and the intercept. So if you're putting something into slope-intercept form and you're trying to classify how many solutions it has, you can see that by what she said. Now, if they both have the same slope, different intercepts, what does that mean? Emily? They're parallel. So if something has the same slope, Marcus, and different intercepts, they are parallel. That means if they're parallel, they're never going to intersect, so that would be no solution. If they have the same slope and the same intercept, what does that mean? Infinitely many. That if you were to graph that, they would both make the same exact line. Infinitely many. Good job. And then different slopes mean what? One solution, right? And then to find that common solution, you can use one of your three methods. Very good. All right. We're going to go ahead and collect the posters. So go ahead and put them in the middle of your team. Put your markers. Yeah, make sure your name's on. Put your markers, scissors, and glue back in the boxes. And your whiteboards in the middle of the table. Scissors, glue, markers in the box. Whiteboards in the middle. All right, for your exit ticket, you need to be listening. Your exit ticket, you're going to work on the back of the pre-assessment. So you worked on the sheet that we did for homework, that's working on linear equations. You're going to do the back side that says working on linear equations, revisited. You're working on that. If you happen to not finish it, girls, I'm talking. If you happen to not finish it, you need to finish your homework, okay? So for right now, hopefully you get it done. But if you don't finish it, you need to make sure you finish it for homework. The revisited side of your worksheet. Yes. All right, I'm coming around to get posters. You're working on revisited by yourself, okay? This is not a partner thing. In the box. So we're going to use this systems of linear equations when we get into the system of linear inequalities to help us to solve for the solution. Same type of thing, except inequalities have some shading going on. Systems are definitely on your exam, and they will definitely be on your EOC, so you need to make sure you understand them, especially linear stuff.